With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question given here is statement 1. Addition of HBr to 1-butene gives 2 optical isomers because statement 2. The product contains 1 asymmetric carbon. So we'll take first statement, then the second one. So first statement gives that the addition of HBr to 1-butene gives 2 optical isomers, right? So first of all, we'll draw the structure of 1-butene, that is CH2 double bond CH, then CH2, and then is CH3. So 1-butene, first carbon will have a double bond and 4 carbon atoms are there, right? Now it undergoes a reaction with HBr. So as we know that HBr gives H positive and Br negative. So this basically H positive acts as an electrophile, and as we know that there are pi electrons here. So pi electron, like pi bond gives pi electrons, and it will attach or attract this hydrogen. Now this hydrogen has two conditions, that it can attach to this carbon or to this carbon. But if we see according to Markovnikov's rule, so addition of a protic acid, for example HX, so to an asymmetric carbon atom, or you can say alkene in this case, so the acid hydrogen gets attached to the carbon with more hydrogen substituents. So hydrogen basically will attach to the carbon having more hydrogen, and the halide, that is X negative, will attach to the carbon having less hydrogen, or you can say more alkyl substituents, right? So according to Markovnikov's rule, so this carbon will it will be attached to this carbon, right? So the compound, the intermediate form will be CH3 single bond CH, CH2 and CH3. So this carbocation is basically a secondary carbocation also. And if we see this in this case, so if I take the another case, so if carbon attached, at least this hydrogen is attached to this carbon, so there will be a carbocation which is primary, right? And accordingly, we know that the stability of carbocation is tertiary, then secondary, and then primary. So secondary is more stable, so this secondary carbocation is more stable. Now bromine is acting as a nucleophile, so it will attack to this carbocation here, and the product formed will be CH3, CHBr, CH2 and CH3, right? Now it is given that this reaction has the product of this addition gave two optical isomers. Now for optical isomerism, basically optical isomerism is referred to as the compounds which have same formula, same atoms and molecules, but differ in spatial arrangement, right? So for a compound to show optical isomerism, it should be optically active, and to be optically active it should have a chiral carbon atom. So chiral carbon atom basically is that atom which has 4 different atoms or groups attached, right? Or you can say there should be a stereogenic carbon or a chiral carbon, or also in other words you can say that it should have an asymmetric carbon, right? It is one and the same thing. So if we see in the figure here, like the product here, so this, if I see this hydrogen, I can draw it here. So this carbon has 4 different groups attached and atoms, right? So this is a chiral carbon, or you can say it is optically active. So it will show 2 isomers, and also to show 2 isomers it will show enantiomers which are basically non-superimposable mirror images, and they are known as enantiomers, right? So this statement is correct. And the second statement gives that the product contains one asymmetric carbon. Yes, this is one asymmetric carbon because as we see that asymmetric carbon is the chiral carbon which has 4 different atoms or groups attached. So this is the correct, because first statement is correct in accordance with the second statement, right? So this is the required answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.